Okay, so welcome back to COP1334, Introduction to C++ Programming. I'm Professor Lesby, and I wanted to create another tutorial video on one of your assignments here from Chapter 8, and it's basically an election results program that you're supposed to put together. And what I've done is I've gone ahead and put the requirements here, and they want you to write a program that basically allows the user to enter in the last names of 5 candidates. For example, in a local election, and not only do they want the last names, they want the number of votes received by each candidate. The program should then basically output each candidate's name, the number of votes received, and the percentage of total votes received by the candidate. When the program's done running, we should see output that looks something like this, right? Where you have the candidate's last name in the first column, the votes received in the second column, and in this third column, percentage of total votes. And you'll notice that this percentage of total votes, the user never enters in this information. We're supposed to take all of the information that the user put in about the candidate and the votes received in order to calculate the percentage of total votes. Not only do we need to calculate this, we need to, before we can calculate the percentage of total votes, we need this grand total number down here. So that's another calculation we're going to have to make. And then finally, we need to look at all the votes received, find out which particular candidate had the most number of votes. In this particular instance, as Duffy. Candidate Duffy here had 6,000 votes. And last but not least, the program is supposed to basically explicitly tell you which one of these candidates won. Of course, in this case, it's Duffy. So there's a few processes involved with this program. And the other thing we really need to key on here is that anytime we have multiple pieces of similar information here, okay, that should immediately key to you that you need to use arrays. Okay, you don't want to use a unique variable name for each one of these pieces of information. Why? Number one, your program's going to be really ugly if you do. Number two is it's just not scalable, right? What if instead of 5 candidates, what if all of a sudden we had 100? What if all of a sudden we had 1,000, right? If we don't use arrays, our employers aren't going to be very happy, number one. And number two, it's just not scalable. So keep that in mind, that this solution, we need to use arrays. All right, so the first step in solving this particular problem is that we need to come up with the pseudocode. And the pseudocode is basically, at a minimum, what we need to do in order to design the software. Is we at least need to put down each step that we think is involved in creating this program, because we need to kind of think through things before we just start putting code together. So with that said, here's what I basically came up with for the pseudocode. And again, this is not a quick process, right? Software takes time, and you really need to that really needs to hit home, because software is not a quick process. This particular pseudocode here, I think it took me about an hour and a half to come up with all of the pseudocode, just because I was constantly revising things, figuring out what parameters needed to be used, what return values, what input, process, and output. You know, the short version is what input, process, and output was involved with each one of these modules and functions. So keep that in mind, that just designing a software takes a little bit of time. And then in theory, if you design it correctly, I think the implementation of this took me maybe 20 minutes once the pseudocode was done. So and when you implement it, if you design it well enough, if your pseudocode is good enough, you're going to have minimal logical errors. You're going to have minimal, in theory, syntax errors if you design things up front. So you're going to spend less time debugging if you actually do some pseudocode and think through things. All right, so enough about that. What did I do? You know, basically, I always like to include a header in all of my files. And I also always like to put pseudocode right directly into my CPPs so that I can just put the code in afterwards underneath of the appropriate pseudocode statements, so that basically I'm taking my design and it's documenting the code for me, so it's not a lost cause. It's not something that I'm just putting on paper and then after we code it goes away. Hopefully the pseudocode is good enough to really help document what it is exactly that we're doing. So with that said, the very first thing that we needed to create here is I threw together a main function, right? Every program starts with main, okay, and that's just true for every application out there. If you don't explicitly see main when you're looking at software code, there is a main somewhere under the hood that is starting the main program, and in C++ we always start with main. So with that said, we always want to think about input, process, and output, right? And in particular for this main module here, we're going to see that for the input, there is a way to pass input to a main function. Okay, I don't want to give you guys the false impression that there's no way to pass input to a main function. There is. There's just a certain way that it needs to be done, and really that's kind of its own topic in and of itself, which it's definitely, I have it on the radar. I definitely will create a lesson one of these days explaining how we can create main functions that actually take input parameters and actually return values. But for the most part right now, we don't need any main functions that take input, which is why I don't provide any parameters to main, and that provide output. So right now we're always using void main functions, and that's why. But the reason I bring that up is because void main basically means we have no input and we have no output, right? No input from any other functions or the outside world, and we don't need to return anything to the outside world. So that's why I put input and output. Concerning the process here, we basically want a program, right? And we just read over these requirements that's going to allow the user to type in 5 candidates' names and the votes they've received, right? That's the whole purpose of this program. So that's about as clear as they get, and there's no additional instructions here. It's basically up to us at that point to design a program that's going to do this. Okay, so how do we do that? Let's go ahead and take a look at main. And again, what we want to do is we really want to figure out what processes, what modules are needed in main. Okay, when you do the pseudocode design, really look at main first, and then flush out all of the helper modules that you've created with main next. When we go to implementation, you're going to see that when we go to implement the pseudocode with actual C++ code, typically you start with the helper modules and you put the implementation into the helper modules first, and then you come back to main. So it's kind of the reverse process when you're implementing the pseudocode. So kind of keep that in mind, that when you're designing pseudocode, you want to design main first and then the helper modules. When you're doing implementation, you want to do the modules first and then main. So for main here, since we have no input provided, right? We just went over that, right? The input is none. We're not passing any parameters to main, so we have no input from the outside world. Because of this, we basically have to obtain this information that the program is going to use directly from the user, the file, or even the internet. And in this case, we basically want the user to type in this information directly. So you always want to think about that when you're creating main. You need to ask yourself, where is the input coming from? And most of the time it's coming directly from the user, either with their mouse or with the keyboard. But there are some programs, a lot of embedded programs, where the input does not come directly from the user, does not come directly from the mouse, and it comes from different input devices, sensors, telecommunications, things like this. So just keep in mind that each program doesn't always accept input directly from the user. We can have programs that gather input from using other means. Okay, so once we know this, we know that we basically need to create an array that's going to store the candidate's last name, how many votes each candidate received, and the voting percentage for each one of these candidates. So we need to create these arrays that are actually going to store all this information. That's kind of step one, right? Taking a step back and saying, okay, what variables do we need in order to store all of this information? And that's what this pseudocode here represents. Okay. Now you may not know ahead of time all the variables that you need, right? I've always said you can always go back and add variables as you need them, but in this case here, it's pretty cut and dry that we have 5 candidates, and these are the pieces of information that these candidates need. So it's fairly easy to see that we need 1, 2, at least 3 arrays with 5 pieces of information in them. One is for the candidate's last name, one is for the votes received, one is for the percentage of votes received. So that's how I basically came up with this portion of the pseudocode. Next, we really want to look and see and say, okay, this is the information that we need, but now how are we going to get this information? And the answer is, well, from the user. Now, because this is a very specialized process, right? We don't want to just come into main here and start typing in CN statements, right? We want to modularize this one single process, what I like to call input candidate info, right? This process where we're basically asking the user for a lot of this information, for all of the candidates' last names, for instance, for all of the candidates' particular vote counts. Okay, this is all candidate information that we're going to input from the user. So that's why it occurred to me at this point, hey, why don't we create a module called input candidate info that excuse me, that's going to go out and grab, right, all of this information, well, most of this information that we need, right, at least the last name and the vote count. So that's how I got for the input the last name and the vote count. Next, anytime we're using arrays, right? Anytime we're using arrays, like the last name, like the vote count, you always need to pass what is the maximum size of that array. The reason being that something called out of bounds, right? If you allocate enough memory to store 5 last names, and you try to store a 6th last name into that array of 5, basically what happens is you go beyond the boundary that was allocated for those last names. So you're going in uncharted memory management territory, and typically this causes the computer to crash. And for a simple program like this, it's no big deal. Program crashes, we restart the program. For critical software, if you go beyond the boundaries of the array and the software crashes, really bad things can happen. So we always want to make sure anytime we're using arrays for input or output, we need to pass in the size of the array so that we don't go outside of those bounds. Okay, what's the process involved here? We basically want to grab all of the information from the user in order to basically take that information and stick it into the last name array, into the vote count array, right? So the whole point of this module really is to pass in these 2 arrays, grab the information from the user, and then place that information inside of those 2 arrays that we just passed in. Now this other output that came to me while I was designing this is not only do we need to place this information into the arrays, we also need to return the number of elements stored in the array, right? Just because we create an array of 5 elements doesn't necessarily mean we actually have five candidates, right? What if we only had 2? What if we only had 3? So the number of elements in this array may not really be equal to 5. So we also want to return that number, so that if we don't use everything in this array, this will allow us to tell the person using this function that we only used a few of those slots. So once we call this input candidate info module, right, now we're basically done here, and we've received all the information we need from the user, all the last names, all the vote counts, and once we do that, we basically want to store off the input, right? Store off the output, and that output is basically stored in the last name array and the vote count array, so we should be good there. All right, so that's the input candidate info. This grabs a lot of the input we need from the user. Okay, so that's basically the input that we need. The next step is we really want to call the calculate candidate info module. This is needed because we have this thing called this vote percentage array. If we look back at the requirements, there's an actual column here, you'll see right here, that where we need to display the percentage of votes for each one of these candidates, and this should be calculated by the computer. Do not make the user who's typing in the number of votes and the last name force them to bust out their calculator to calculate this stuff, because that's our job. That's the job of the computer program. Is it should be able to, if we know all the votes received and we know the total number of votes, we should be able to calculate these percentages. So with that said, that's why we now have this calculate candidate info module. This module should basically, if we look at the process, calculate the total vote count and the different voting percentages for each one of these candidates. Now, if we want to do this, what do we need? Well, for input, we need that vote count array, right? Give me the array that has all of that information inside of it, as far as what candidate and how many vote counts they each received. The other thing we need is this vote percentage array, right? Once we calculate all the percentages for the candidates, we need an array to stick all these to place all of these percentages in, so that we can access them later. And then finally, for input, the number of elements stored in the array, right? Because we're accessing these two arrays here, you don't know how big those arrays are, you don't know how many elements are in those arrays. So anytime you're passing arrays as parameters, make sure that you know the number, specifically the number of elements that are in that particular array. So that's kind of the third piece of information that we need. Once we have this information, once we calculate the total vote count and the vote percentages, we can basically place all of that information into the vote percentage array, right? So the vote percentage array is actually going to store all of our output, because that's half the reason we're calling this function, is to get all of these vote percentages. So we're going to store all the output in vote percentage array, and we're also going to have a total vote count, right? That we can return, so that just for informational purposes, you know how many total votes were used. But the most important thing out of this is definitely the vote percentage array that's going to give us the different voting percentages for each one of these candidates. Once we do this, we need to make sure we store off the output, right? Because it looks like 2 outputs are being used here, we may not have a return statement. The output may just be stored directly into these parameters. We'll have to see, but this is a step that a lot of new programmers skip, and they forget to store off the output. So please, just because you call a function doesn't mean that you may not have stored off the actual return value. So always be careful. For return types used, you need to store off the output when you call this particular module. Okay, so now that we've input all the data from the user, now that we've calculated all of the different percentage numbers, why don't we go ahead and call the determine winner module? And this module is actually going to look at everything in the array and let us know who actually won the election. Okay, now you have to ask yourself, well, what do you need for a module like this? What kind of information do you need as input? And the answer is, well, you need the vote count array, right? We need to be able to look at each one of these different vote counts. We need the last name array so that when we figure out which one of these vote counts won, we can correlate that to which last name was the candidate that had that vote count, right? Because without this last name array, we can't really explicitly say who the actual winner was. We also need the number of elements stored in the array. Again, anytime we're passing arrays, you also need as that next element the number of elements stored in the array in order to prevent out of bounds errors. Process, well, yeah, we process all the vote counts and we find the highest. That's the whole point. Let's find the candidate with the highest number of votes, and let's find the last name basically associated with the candidate with the highest number of votes, and then let's return let's return that last name so that we can actually display that to the user. Why do I say that? Right here. We need to be able to display who is the winner here, right? And so that's really what's driving this return statement here. This last name of winner is that we need to show that. All right. As far as the once we've determined the winner, once we've determined the percentages, well, hey, let's just go ahead and display all of the information, right? Which is basically all of the last names, all of the vote counts, all of the vote percentages, right? If we go back here and we look at the output, we need last names, votes, percentages. So that's why you see display candidate info taking these three things in as input. And again, because we have arrays, we need to pass in the number of elements stored in the array. What's the process? We want to display this candidate information basically in nice little pretty rows and columns like the requirements ask us to do. Okay, so that is basically the pseudocode for main. What do you do after you create the pseudocode for main? Typically what I do is I go back up and I grab the first module in main and I basically highlight all of the information about that module, all of the input, the process, the output, and I'll copy it and I'll basically paste it directly down below main. I'll give a little more clarity to it, right? I'll give it a nice little description letting me know what it was supposed to do. I'll give each one of these input parameters variable names so that I can be very clear when I include comments what these variable names are, right? For the output, the same thing. I give nice little variable names to all of the output so that I can be very clear. And once that's done, okay, then I put a nice little placeholder, right? It's just a void function placeholder. This does not mean that this function is going to end up as a void function with no parameters. It just means that for now I'm going to say that, you know, we know there's going to be this function called input candidate info. Why? Because it says it right here, input candidate info. I worry about the actual return value. I worry about the parameters listed here and their types during the implementation phase. We're still in the pseudocode phase, so I don't go too crazy with this. I just put a void function with the name of the module. Next, I basically copy and paste the process. What is it that this module is supposed to do? Input candidates info from user. All right, well, if we want to input the candidates info from user, we want to put all of this information into these arrays, like last name, right? Like vote count. And because we want to put all this information into the actual arrays, we need to create a loop for the arrays that's basically going to count from 0 to the maximum number of candidates. And the maximum number of candidates is basically the maximum size of this array. So we're guaranteed not to go out of bounds as long as our maximum number of candidates, which is right here, it's part of our input, right? As long as the maximum number of candidates is correct. So we're going to create a loop, an I variable loop that's going to go from 0 to max number of candidates. We're going to prompt the user to basically put in the candidate's last name. Then guess what? We're going to input that candidate's last name into the appropriate slot of our last name array. Same thing with the vote count, right? We're going to put that, well, it's not actually the last name, it's the vote count. Okay, we're going to input the vote count into the AR vote count array slot. And then because I basically ask the user if they have any more candidates, I prompt the user if they have any more candidates. If the response is no, I kind of included the ability to break out of this loop early. So, for instance, if we don't have 5 candidates, maybe we only have 3 candidates, okay? I put the ability to do that so that if there's only 3 candidates, we can break out of this loop early. Now, if you do that, we need to make sure we have another variable called num candidates, right, to store how many times did we loop until the user was finished. Because if we just depend on I, that may not be an accurate count of how many times we actually looped here. So that's why I went back and included this number of candidates variable to actually kind of remember for me how many times have we actually looped here in case we break out of the loop early. Okay, because if we use I, we have to be really careful using I. I just felt it was a little bit more clear if I kept a separate variable called number of candidates that would store how many candidates were actually stored in our array. So that's kind of where that came from. Okay, so this here you could argue is optional. Okay, this stuff here you could argue is optional. This here is not. This is the actual prompting of the user. Please enter in their last name. Please enter in their vote count. Calculate candidate info module. Okay, this is where we actually calculate all of the percentages. Okay, and again, I just copied and pasted what was up in main. That tells me what all my input is, right? What parameters are coming into this function. It tells me what my output is, and it says, hey, this particular function is supposed to calculate the total vote count and vote percentages. That's the whole purpose of this function. Calculate candidate info. Now, if we look inside of calculate candidate info, we are going to see that before we can calculate the percentages, we need to calculate the total vote count. Okay, so we don't really have the total vote count. We have an array of vote counts, right? If we come back here, we have an array of values here that that each candidate received, okay, but the user never told us what the actual total vote count is. That's up to us to find that. So in order to find the total vote count, instead of putting a loop here to calculate that, I created another function called get total vote count. Okay, once I did that, I said, you know what, this total vote count is basically going to need the vote count array. It's going to need the number of elements stored in that array, and in theory it should loop and basically return the total vote count. It should look at all the vote counts inside of this array, add them all up, and return the total vote count for us. Okay, so that's what the get total vote count module is supposed to do. It's supposed to loop through everything, basically calculate the total count. And so when this guy returns, when this module is done, get total vote count, we are then at that point going to have the total vote count we need for the percentages. Okay, so once we have that, we look at the loop. That this is the big process. We basically want to create a loop that's going to go from 0 to the number of candidates, right? The number of valid entries in our array, and we want to calculate the voting percentage for each candidate. In order to do that, what we're going to say is basically take the vote percentage array, take the appropriate element out of that vote percentage array, or access it, and just set it equal to the vote count that the user gave us, right, divided by the total vote count. Where did we get total vote count? Ta-da! Right? That's the whole reason that we use get total vote count is this piece of information was so important that we needed to basically get it first before we could use it for the percentage. Okay, so this is how we're gonna we basically calculate all of the voting percentages that you see in the column. The get total vote count, this is basically, once I figured out I needed this, I copied and pasted this down below, right? And the whole process with get total vote count is that we're going to basically create another loop where we are basically going to add AR vote count, right? All the vote counts in the array to this new guy called total vote count, and then we're going to return it. So the whole purpose of this function here is to just loop over all the vote counts and return it. And then finally we have, no, not finally, we have a determine winner. Okay, the whole purpose of this function is to process all the vote counts and find the highest one, right? How do you determine the winner? Who has the most votes? Now, in order to do this using code, what we need to do is create a variable called highest vote count found. Okay, the computer, the computer's not smart enough to just look at a list of numbers like we are and pick out the greatest one. We actually have to have a new variable called highest vote count found that's going to store the highest vote count seen at that point. And the highest vote count seen, the only way we're going to be able to do that is basically look at every value, right? Look at every value that was stored in this vote count array. How do we do that? We need to use what's called a loop. We have to basically loop over all of these vote count elements in the array, right? Here's our input right here, AR vote count. Loop over all of these vote counts in the array, and we want to check to see, is that vote count greater than the highest vote count found, right? So basically, as you look at each number, say, is it the biggest one I've seen yet? Is it the biggest one I've seen yet? If it is, right, now we want to basically set the highest vote count found to that particular vote count. Okay, and it may be that this actually happens multiple times, right? Because if our vote count, let's say candidate 1 had 4 votes, candidate 2 had 6, candidate 3 had 8 votes, it may be that after the first one you think 4 is the highest. Until you see the second one, you think 6 is the highest. Until you see the third one, 8 is the highest. So this highest, these 2 lines of code here may continuously kind of overwrite the previous finding, and that's okay. All right. Highest vote count found is just the highest vote count found at that point in the loop. When the loop is all done, though, right? When the loop is all done, that means that we've looked at every element in the array, and we can officially say that the highest vote count found, that is officially the highest vote. Okay. If you've gone through every number in the array and you've stored off the highest one that you've seen, you know that the highest vote count found is the correct highest vote count. Now, if you go through only halfway through the array, let's say you do a loop and you only loop over the first half of the array and you claim to know the highest vote count found, yeah, that doesn't work. Okay, so you always have to go through every element of the array in order to find the highest vote count. Now, there are more efficient ways. This is what's called a linear search. Okay, and it's not the most efficient thing in the world, right? For 100 votes, no big deal, or for 100 candidates, no big deal. But when all of a sudden you start dealing with numbers like millions and tens of millions, now efficiency of the algorithm matters. Linear searches take a very long time, and there's much more efficient searches that you can use that won't look over every element in the array. That's another class altogether. That's a data structures a class where you can do all sorts of fun stuff. So maybe at some point in time, I'll see if I can do a video on some fun searching algorithms. All right. So once we've found the highest vote count, at that point we can actually declare what last name was associated with that highest vote count. All right, now finally, last but not least, we do have the display candidate info module, and this whole the function of this. The whole purpose of this function is to do nothing more than to take all of the information in the arrays, right? All the information in the arrays. We know that there are this many elements in the array. That's the purpose of this fourth piece of information, the number of candidates, and to basically loop over, right, all of these elements in the array and display their last name, vote count, and percentage in the appropriate format. Okay, so display candidate info does nothing more than loop over everything that's in the arrays and display them. Okay, so that is the pseudocode design for the election results program. If you watch part 2 of the election results program, I'm going to show you how the pseudocode maps directly to C++ implementation. So thank you very much, and I look forward to your submissions.